show you, thank you all. It's so nice to see your faces. That's one thing I wanted to say at the final. You know, I don't make a big deal about you guys having your cameras on because I know it can cause problems with your Wi-Fi for a lot of you. Let's see. I don't want you ever to feel uncomfortable about having your camera on with me. But I know that some of you, it's real and it's a problem. So I'm pretty forgiving on that. But I have to tell you, when I saw your faces on the final day, that was really, that guy's teaching for real. Kind of silly, huh? So here's today's calendar. I made all new Google Classrooms for second semester. So I tried to get a code that was workable, but since you're already signed into the Google Meet, you should already be in there. It's my understanding. But if you have problems, let me know and I will email you a link to join. I want to go over electron configurations. I know that's where we left off. We were kind of rushing, and it was, we really just needed a couple more days, I think, to make y'all feel comfortable. So I did look at some of your work over the break, the last couple of days, and I think we need to go back through electron configurations a little bit because it's going to be really important to talk about chemical bonding and stuff that we're going to be doing soon. The new classroom code you have, I made a Google Forms survey that I'd like you to complete. It's mostly, it's kind of a reflection, and so I'll talk to you about that after we go through the electron configuration review. I haven't used Remind this year because we are so tied in with Google Classroom. I don't see it as a necessary extra thing for you to get a reminder on. But if you think it would be helpful, if you don't feel like Google Classroom's enough, you can always tap into this, and it works just like a text message. You probably know that from other classes. I had it up in August, but I didn't really emphasize it. I had a couple of physics students use it because I had used it more with their chemistry class last year. So I don't know. I'll leave it up to you if you want to bother getting into Remind, but if you do, this is the link for chem for me. But again, all the information you need is going to be on Google Classroom, so I'm not going to, if you need to like message me, you can get to me on Google Classroom too, and of course through email. All right, let's get out of that. So what I did when I built the new classroom is I pulled up all the things that I thought you might need for reference material. Okay, so the course syllabus, which you got in August, just gives you an outline. We're not as far along as we should be. Yay, quarantine. The rules for the class, some of you like to do Cornell notes or like that style. You don't have to have the template. You can do it on the course. I threw in the pictures of the classroom. I looked at them yesterday and I was like, oh, I miss being there. The safety contract, again, the lab equipment lists, lab report format, which again, we haven't really done formally at all. Different times, but I wanted it to be in there in case you ever do lab reports somewhere else or later this year when we go back to campus. How to make a Google Sheets graph. I decided to pull that up because we will be making more graphs this semester. This is the list of topics. If you don't need to turn it in, whoever turned it in, bless your heart. It's not really assignment. There's no grades. This is just for you to have. So I just pulled it up from last semester, which is why it comes up as an assignment. It's not really an assignment. This was the list of all the videos on how to use your calculator, because you're going to need that again. And then I had a second thought that we should make sure that you have a reminder on how to do significant figures. All this stuff is at the back. A lot of this stuff, I should say, It's at the back of your textbook as well in the reference section, so shouldn't be it shouldn't be hard to find. And of course there's things online too, but I wanted this here so you can use it. And then I put a copy of the periodic table. I may change out this version, but this is one from the main company that I get my chemicals from. There's another one on the slideshow today that I may switch this out for because I think it's a little easier to read, but I'm going to leave that without a topic. So because you're going to want to, so if I do that, it stays at the top of the classwork stream and you'll be able to access it more readily. Again, there's one in your textbook, there's one in the back cover and in chapter 6 in your textbook. But by the end of this week, we're going to be diving pretty heavy into the periodic table, and I want you to have that handy. All right, what else did I want to tell you? So that's the stream. Let's see, we got everybody in here. Oh, nicely done. Okay, it looks like you all succeeded. Good job. So that's the classroom, and again, in the classwork is the survey. We'll come back to that. But what I'd like to do right now is look at, it's a PowerPoint you've already seen. I've already done a lecture on this, so I'm going to go pretty fast. I want to make sure you understand this because it's really, really, like I said, foundational to your futures. It's going to come up again and again. I'm sorry, does anybody have any questions right now? I should start there. Any questions? I lost you guys. Oop. Anything I can answer for you right now? Well, don't be shy. I know you guys aren't. Thank you. But let me know if I can answer anything. So here we go. All right, so electron configurations. Remember we learned that there's particles in atoms, right? Thomson and then Thomson found the electrons, Rutherford found the nucleus, ultimately the protons were there and the neutrons. The question was, where the heck were the electrons? And Bohr had this, well, Rutherford also had this vision of them circling like the planets circle the sun. That kind of sticks for everybody. It's not really true. Bohr realized there was something going on with energy. You had to have a specific energy to be a specific distance from the nucleus. That explained those spectral lines, those pretty colored lines that scientists had observed for years prior that couldn't be explained, and why were they different for every element. Turns out it's about their electrons. Okay? And again, as the protons change in the nucleus, that creates a different electrostatic force on those electrons. So it's going to take different amounts of energy in different atoms for those electrons to move around. They get excited, they fall back down, they give off energy. Okay, so the question was, where exactly are they? How do you find them? And it turns out you really can't find them that well, but we use quantum numbers to find their location or their address. I went through that explanation of how you address an electron or electron's position. And there's these weird things called sublevels that are shapes. The most important one, or the first one, is that energy level, the principal quantum number. And that corresponds to layers on the periodic table, the periods on the periodic table. That tells you how far maximal distance is for that electron, 90% of the time. Second quantum number gives you these weird shape things that we talked about, the SPDF cloud shapes, the regions around the nucleus where they can be. The third one was the magnetic quantum number, which gives you orientation in 3 dimensions, like a compass, the magnetic compass. And the fourth one has to do with how you can have 2 negative things in the same region. One has to go one way, one goes the other way. It's the way the physicists explain it. Okay, the S sublevel just has 1 orbital, and every single period has an S sublevel. P sublevel has the px, py, pz, starts at the second energy level, or period 2. These are the weird phases with the donuts thing. F's are the freaky flowers, right? So again, period 1 is energy level 1. Period 2 is energy level 2. The nucleus would be up here at the top somewhere. This would be layer 1 of electrons. Hydrogen only has 1, helium has 2. That layer is full in our little atom onion. Okay? Starting with lithium, we get to another layer with those weird size steps. You know, they're different distances. They're not uniform in size. Layer 3, layer 4, etc. Okay, and then we went through the rules. Excuse me. Aufbau, Pauli exclusion, and Hund's rule. And Aufbau says you got to fill the lowest first before you can climb your ladder and get away from the nucleus. I know I'm going super fast, but I've already gone through this with you guys. And if you want, I can, well, I'll post this again and you can stop and start it as you need to. Pauli exclusion principle says no two electrons could have exactly the same address. Okay, so they're going to have a slight difference. Okay, they might be on the same, in the same state, in the same city, on the same street, but they're in a different place. They have a different fourth quantum number. And then Hund's rule was the seats on the bus rule, where we're going to half fill all the possible positions before we start doubling up. Everybody wants their own seat. And again, there's different ways to do it. The first way that we learned was the expanded filling, where it makes conceptual sense. Low energy at the bottom, high energy at the top, further from the nucleus. There's a way to do that with just a single line. Not that useful, I don't think. Expanded electron configuration. This is the one. This is the secret shorthand that chemists use. 1s2, 2s2, 2p6, 3s2, that kind of stuff. Okay, remember those s2 means 2 electrons, not squared. And what we really need to learn about is this noble gas configuration. I may say that for tomorrow because I don't want to take up all your time today. All right, if you know where the element is on the periodic table, you know where the last electron is loaded on that atom. Doesn't mean it's going to live there all the time. Remember, it's just a 90% probability. Okay, so you just need to know how many electrons an atom has, what energy level the element is, what line on the periodic table it's on, what block. A lot of you didn't catch the sublevel is signified, or the sublevels, the S, P, D, F shapes of the orbitals, the regions or blocks on the periodic table, not the little squares for each element, but the whole big region of several groups, tells you the shape of the last orbital. And then you need the rules. And then the goal for elements is to complete their S and P orbitals, get their octet. So again, this has it on the bottom, which is another reason why I think I'm going to put this one up for your viewing pleasure. But these first 2 columns, along with helium, these are the S block. Okay? The next 6 columns, excluding helium, those are the P blocks elements. Their last electron goes into a P orbital. These 2 columns, their last electrons go into a S orbital. The middle group, the transition metals, their last electron goes into a D. And these down here, which we'll never, ever, ever, ever do, are in an F orbital. So you might remember I had a star on one of these. I don't even remember which one it was. Just by knowing it's element 33, just by knowing it's on the 1, 2, 3, 4th line in the P block, in the 3rd column, I know it ends at 4p3. And then because of Aufbau, all the other orbitals have to be full. Okay? So 1s2, 2s2, 2p6 gets you to neon, 3s2, 3p6 gets you to argon, 4s2, remember this is 3d10, 4p3, that is the configuration, the electron configuration of whatever element 33 is. This column, the last one, group 18, used to be called group A, and I'll explain the A and B things. You'll see it on, when you're in the classroom, the periodic tables on the walls have this A and B notation. I never got it in college even. I didn't understand what in the world, why are they A and B? Just go 1 through 18 and be done with it, which makes it more sense. But there's a reason for this. I'll try and explain it better. So again, these helium, neon, argon, krypton, xenon, and I don't remember what these are, radon, and I don't know what this one's, octium, I don't know what its new name is. These are the noble gases. They're non-reactive because they have S2P6 as the end of their configurations. Remember again, this F block should really be in between the S block and the D block, down at the bottom. And this is the slide that I showed you before. And again, these numbers correspond to the periods for the S and Ps. In Ds, they're offset by 1, and the F block, they're offset by 2. Okay, so this is the expanded filling. Remember, there's just a slight difference. 4s is at the 4th energy level, but there's only 2 electrons to hold together. The 3d has 10 negative things trying to squish together. There's a little repulsion, takes a little more energy to hang them together. So the 3d comes after 4s and before 4p, which is irritating for sure. And that was our practice, and that was the, oops, that's the compact. It's the same thing as the stacked, it's just in a continuum. So if I was on the 1st energy level in the S block in the 2nd column, that would be helium. And then this is a trick to help you remember filling order. Again, you can start at the bottom with the lowest energy, 1, 2, 3, 4, 5, 6. Every layer has an S. Starting at the 2nd, they have P's. Starting at the 3rd, they have D's. Starting at the 4th, they have F's. This one is more in line with the orientation of the actual periodic table. Okay, 1's at the top, 7's at the bottom, but it's the same idea. All of the layers have S's. Starting at the 2nd, they have P's. The 3rd layer, they have D's. At the 4th layer, they have F's. Okay, there. I'm going to stop right there and come back to this tomorrow. And we will go into noble gas configuration tomorrow. So on the survey, I'd like to show that to you. Any questions about what, it's all of that was review. Does anybody have any questions? Okay. So, probably some of you already peeked. Let's see. Yep, 5 of you already done it. You stinkers. You're supposed to be listening to me. Gosh darn kids. All right. I usually do a journal activity where we make goals for ourselves. And so I kind of modified it a little bit. I want you to think about how you feel about the coming semester. Goal settings are a really important thing to do if you want to improve in your future, which all of us do. New Year's resolutions are just, you know, the new year you kind of focus on, what do I want, right? And everybody jokes like, why make them? Because they never come true. If you never make goals, they won't come true, that's for sure. So one thing that I like to also emphasize is that most of us are our own worst critics. We pick on ourselves a lot. We find every fault that we have and want to fix it, but you're already doing really good things. You're doing good things at home. You're doing good things at school. You're a good human being. You're a good friend. You do work at your church, whatever it is. Okay, so list some things and pat yourself on the back that you feel like you're doing a good job at. Maybe you're a good big brother or big sister. Maybe you help your neighbors that are elderly. I don't know, but you know, give yourself some credit for doing good things. Okay, and then of course, all of us need to improve. It's a journey, right? We always are working on ourselves. So one of the things with goals, it's not just enough to say, I'm going to do good at something. You want to set a goal. So the classic, I'm going to get good grades. Okay, but what does that mean? For every person, that's different. Okay, so you're going to end the year with a 3.5 GPA for the semester, for your career, I don't know, or whatever. I just want you to put something specific so that, you know, we like to quantify in science, right? Something that you're going to strive, that you think is worthwhile to work for. And it could be, I'm going to pick up my room once a week. I'm going to clean the bathroom once a week. It could be, I'm going to help my little brother with their homework once a week. Put something, quantify it, not just vague generalities, okay? And then some other things that I'd like you to do is give me some suggestions, some things that would help you for the coming semester. I just threw in some stuff that I thought of. You can add in multiple things. And then I wanted some feedback on things that you found helpful. I'm going to really emphasize that you take handwritten notes. I read some things, and my husband and his brother talked about some really interesting research that actually doing pencil to paper really does make a better connection in your brain. There's this whole and distraction of the internet and all of our devices, and we're not good at focusing unless we're actually manually doing it. Anyway, these are just some things I thought of. Obviously, you can think of others, and then anything that I didn't think to ask that you would like me to address or help you with, please, please give me your feedback. And I will tell you that my goal is to do my utmost to get work graded the same week, whether that means the weekend or not, so that you have more immediate feedback. I think that's a huge failing of mine, and I apologize. I'm trying to create stuff for online, have all the stuff in my room, but I have to make it so it's online, and that creation process takes away my grading motivation. So I am definitely going to be focused on that for you. And I'm going to focus on getting grading done today as well. So is there anything I can do or answer for you right now? All right, well, welcome back. We got this. Hopefully in a couple of weeks we'll be able to make it onto campus again. And I hope that you had a really nice break. I will let you go for the other 19 of you that haven't done your survey yet. Have a good Monday. See you tomorrow on this link. And take care. Stick around if you have any questions.
Bye, Miss Sketches. Thank you.
Bye, Emma.
Thank you.
Thank you.
Thank you.
Thank you, Kimberly.
Thank you, Miss Sketches.
Bye, guys. Thank you, Luke. Bye, Amber. Bye.